Hello learners and welcome to your natural sciences lesson. So today we're going to be dealing with practice questions that are based on pressure. So now let's start. We are given this question here and they want us to refer to the diagram and answer the following questions. So the question is, describe what is happening in the diagram with reference to the number one, which is now the collision of particles with the wall of the container. So we have this diagram and the first one has cool gas and the second one has hot gas. We need to now describe what is happening in those two pictures when referring to the collision of particles with the wall of the container. So we know that when the gas is cool and comparing that with the hot gas, the cool gas will have the least amount of energy. So the particles that are inside this container will have the least amount of energy. And as a result, the number of collisions between the gas particles themselves and the wall of the container are going to be slightly less at low force. The force that is exerted by these particles onto the walls of the container is going to be less as compared to the force that is exerted by the gas particles to the container when the gas is hot. Why? Because energy here is high and then energy here is low. Right? So then, let's now answer the question. Describe what is happening in the diagram with reference to the collision of the particles with the wall of the container. So, starting with the cool gas. So, there's going to be less collisions. There's going to be less collisions per second. Which will then result in less pressure. That's now for the cool gas. Now, what about the hot gas now? Hot gas. Obviously, if now the gas is hot, that means they have increased the energy. So there's going to be more collisions. More collisions per second. Between the walls and the particles. Between the walls and the particles. And we know that once there's more collisions between the walls and the particles, there's going to be a lot of force that is exerted between the walls and the particles, and as a result, the pressure is going to increase, or therefore we can say there's going to be high pressure as compared to the cool gas. Now, second question is, same picture that you are given, but now we need to describe what is happening in the diagram with reference to the energy of the particles. So, cool gas, and then hot gas. Now, the cool gas, the particles there will have less energy. And then the hot gas, the particles there will have more energy. And once they have more energy, we know that they're going to move around more often, and the number of collisions are going to increase once they have more energy because they are just moving around excitedly so. And they're going to collide more often, and as they collide more often, the number of collisions are going to increase between the particles and the wall. And then the force that is going to be exerted by the particles onto the wall is going to be increased again. And once the force is increased, the pressure is also going to increase. So more energy is going to result in high pressure, and less energy will result in low pressure between the particles and the wall of the container. Now, pressure in the container, as we have said, this is cool gas here. Cool gas. There's going to be less pressure. and then hot gas, there's going to be more pressure. There's going to be more pressure when the gas is hot. So let's quickly write that. Pressure. So that's what is going to happen when the pressure in the container is, when the gas particles in the container are hot, and also when the gas particles in the container are cold or they are cool. The difference in terms of the energy will result in the difference in terms of the pressure. So the next question that you're going to be looking at now is, we need to now refer to the diagram and answer the following questions and describe what is happening in the diagram with reference to now the volume. So we looked at pressure, we looked at the temperature, the energy, so now we're going to be looking at the volume. What happens to these two pictures that we have here when the volume is changed? Because we can see on picture number 1, there is a larger space for the particles to move, but on picture number 2, the space for the particles to move has been decreased. And remember we said that the relationship between volume and pressure is that the higher the volume, so V and P, volume and pressure, when volume increases, there's going to be less pressure. Why? Because now when we're increasing the volume, we are giving the particles more space to move. And once there's more space to move, chances are they might not even collide as frequent as they would if the space was decreased. We can take you, for instance, again, which is to say that we take two particles, you and your friend, will lock you inside as a hall. We can think of the biggest hall that you can ever think of. We lock you inside there, and we say we blindfold you, and then we say move around. So there are chances that you may not even collide into each other, right? But then if I now decrease the space, the size of the hall into, let's say, a classroom, same number of particles, and then I blindfold you again and still say that you as the gas particles move around. The chances of you colliding to your friend are going to be increased as compared to the chances of you colliding to your friend in a much bigger space. Because there's less space for you to move around, there are more chances of you colliding with your friend. So therefore, when we are increasing the volume, the pressure is going to decrease. But once we are decreasing the volume, the space, there's going to be more pressure because there's going to be more collisions. So therefore, to answer the question, describe what is happening in the diagram with reference to the volume of the container. So picture number one, more volume, less pressure. There's less pressure. Why is there less pressure? Because there's going to be less collisions. Right? Now, when looking at picture number 2 is going to be the opposite of this. There's less volume, as we can see. The lid has been brought even closer down, so therefore the space is small as compared to the first picture. So there's going to be less volume, and once there's less volume, there's going to be more pressure. And once there's more pressure, means that there's going to be more collisions. There's going to be more collisions. So that's what is happening with regards to the volume, that the picture number 1 has more volume for the particles to move around, and once they have more space for them to move around, there's going to be less pressure, and less pressure will mean that there's less collisions. And the opposite is true. Once there's less volume for the particles to move, there's going to be more pressure, and more pressure means there's more collisions per second that are happening, either between the particles themselves and also the particles and the walls of the container. Next question. We are given that. We also again need to describe what is happening in the diagram with reference to now the collisions and lastly the pressure. We have already answered this question, but then just to quickly recap, the collisions of particles with the walls of the container. In picture number 1, there's going to be less collisions. there's going to be less collisions. Why? Again, picture number 1, because there is less pressure. But looking at picture number 2, remember when we are decreasing the volume, the pressure must increase. So in picture number 2, there's going to be more collisions. There's going to be more collisions. Why is there more collisions? Because, picture number 2, there's more pressure. Pressure will result in more collisions, and also the force exerted by the gas particles onto the walls of the container is also going to be increased. And once that happens, pressure is going to increase. So before you move on to our next set of questions, we're just going to quickly go for an ad break, and I'll see you just after this.